As I have told in my previous video, the type of the boundary condition will have a say over how many number of rows and columns are to be deleted from the global stiffness matrix in the governing equation of FEA. This means if a beam at a particular node is associated with fixed boundary condition, then correspondingly 2 rows and 2 columns are to be deleted. Similarly, if at a node in the beam structural member is having roller support boundary condition, only 1 row and 1 column is to be deleted logically. The 7th point in this particular video tells about the sign convention, which I have already told for a point load and a moment in the previous video. This particular point signifies that UDL and UVL are always having the application direction in the vertically downward fashion. That is, action of the application of the loading of UDL and UVL is vertically downward. So you follow the sign convention of taking negative sign to the magnitude of the load given in a particular problem. Next point tells about the order of global stiffness matrix and in turn individual element stiffness matrices, which is the most important point in solving all the problems of beams and the shafts. That is, the 8th point goes like this: order of global stiffness matrix and subsequently the individual element stiffness matrices is directly proportional to total count of the nodes into 2. Into 2 signifies the point that at each node there will be 2 displacements, one vertical, one angular. Thus the order of global stiffness matrix as well as individual element stiffness matrix is equal to total count of the nodes into 2. In the next point, you students have to remember a formula to calculate maximum deflection or vertical deflection at the midpoint of the loading, in particular UDL and UVL. The formula goes like this: Y max is equal to first matrix. There are 4 numbers. First number is 2 by 4. Second number is LE by 2 into 1 by 4. Third number is 2 by 4. Fourth number is LE by 2 into minus 1 by 4 into second matrix, that is Q, global displacement vector matrix, which depends upon what element it is being referred to. In the next point, we are talking about analysis of shafts or torsion of shafts numerical problems. Within the torsion of shafts numerical problems, the magnitude of rigidity modulus G, radius of the shaft R, diameter of the shaft D, and length of the element L should be expressed in SI unit meter appropriately and logically. Whatever the torque that is being applied at a particular node of a shaft structural member, it should be expressed in SI unit Newton meter, either from kilonewton meter or kilonewton millimeter or kilonewton centimeter, whatever which is given within the problem definition. With respect to torsion of shafts, there is only one type of load being applied, that is twisting moment or the torque, that results in only one kind of displacement, that is angular displacement. Thus, the order of global stiffness matrix capital K and in turn the individual element stiffness matrices K1, K2, K3, K4 and goes on depends upon the value total count of the nodes into 1. into 1 indicates there is only one displacement at each of the nodes of the structural member.